This is SpaceTime Series 26, Episode 80, for broadcast on the 5th of July 2023. Coming up on SpaceTime, a new never-before-seen way to annihilate a star, Australia's new deep space laser communications network, and the unusual origin of the Geminids Meteor Shower. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a new way for stars to die. Most stars in the universe die in predictable ways, depending on their mass. Relatively low-mass stars, like our Sun for example, will eventually lose their outer layers in old age, exposing their white-hot stellar cores, which we call a white dwarf, and they'll slowly fade over time as the white dwarf cools. But stars more than, say, 8 times the mass of our Sun burn brighter and end up dying sooner, and usually in cataclysmic ways, such as a core collapse supernova explosion, resulting in the creation of ultra-dense objects like neutron stars and stellar mass black holes. Stars can also die if they consume too much mass from a companion star in a binary system, eventually exploding in a thermonuclear supernova, or they can be ripped apart by a black hole in a tidal disruption event. Now, a report in the journal Nature shows new research pointing to a long hypothesized but never before seen fifth option. While searching for the origins of a long-duration gamma-ray burst, astronomers using the Gemini South Telescope in Chile uncovered evidence of a demolition derby-like collision of stars or stellar remnants in the chaotic and densely packed region near an ancient galaxy's supermassive black hole. The study's lead author, Andrew Levin from Radboud University in the Netherlands, says these new results show that stars can meet their demise in some of the densest regions in the universe, where they can quite literally be driven to collide. Levin says this is exciting both for understanding how stars die and for answering other questions, such as what unexpected sources could create gravitational waves that we detect here on Earth. Ancient galaxies are long past their star-forming prime, and so would have few, if any, remaining giant stars, the principal source of long-duration gamma-ray bursts. Their galactic cores, however, are teeming with stars and a collection of ultra-dense stellar remnants, such as white dwarfs, neutron stars, and stellar mass black holes. Now, astronomers have long suspected that in this turbulent beehive of activity surrounding a supermassive black hole, it would only be a matter of time for two stellar objects to collide with each other, producing a long-duration gamma-ray burst. The trouble is, evidence of this type of merger has been elusive. But maybe all that's changed now. The first hint that such an event had occurred was seen on the 19th of October 2019, when NASA's Swift Space Telescope detected a bright flash of gamma rays that lasted for more than a minute. Now, any gamma-ray burst lasting for more than 2 seconds is considered long, and these bursts typically come from the supernova death of stars at least 10 times the mass of our Sun, but not always. The authors then used the Gemini South Telescope to undertake some long-term observations of the gamma-ray burst's fading afterglow to learn more about its origins. Now, these observations allowed the team to pinpoint the exact location of the gamma-ray burst to a region less than 100 light-years from the nucleus of an ancient galaxy, placing it very near that galaxy's supermassive black hole. And when they studied the area in more detail, Levin and colleagues found no evidence of a corresponding supernova, which would have left its imprint in the light studied by Gemini South. Levin says follow-up observations suggested that rather than being a massive star collapsing, the burst was most likely caused by the merger of two compact objects. He says by pinpointing its location to the center of a previously identified ancient galaxy, they've had their first tantalizing evidence of a new pathway for stars to meet their demise. Now, in normal galactic environments, the production of long-duration gamma-ray bursts from colliding stellar remnants, such as neutron stars or stellar mass black holes, is thought to be vanishingly rare. The cores of ancient galaxies, however, are anything but normal, and there may be 1 million or more stars, all crammed into a region just a few light years across. Such extreme population densities may be great enough for the occasional stellar collisions to occur, especially under the titanic gravitational influence of a supermassive black hole, which would perturb the motions of stars, setting them careering in random directions. Eventually, these wayward stars would intersect and merge, triggering a titanic explosion, which could be observed over vast cosmic distances. Now, it's likely that similar events are occurring all the time in crowded regions right across the universe, but they've gone unnoticed until now. Now, a possible reason for their obscurity could be that galactic centers are brimming with dust and gas, and that could hide the initial flash of the gamma-ray burst and the resulting afterglow. So this particular long-duration gamma-ray burst, which by the way has been catalogued as GRB 1910-19A, may be a rare exception, allowing astronomers to detect the burst and study its after-effects. This is SpaceTime. Still to come, Australia developing a new deep space laser communications network, and the unusual origins of the Geminids Meteor Shower. All that and more still to come on SpaceTime. Last week on SpaceTime, we looked at the massive upgrade now underway at NASA's Deep Space Communications Network and its primary base stations at Goldstone, California, Madrid, Spain, and at Tidbin Billa on the outskirts of Canberra. Now, as we mentioned last week, part of that upgrade involves experimenting with new high-speed laser optical communication systems, both between spacecraft and between space and the ground. An Australian project is now underway to develop an operational optical laser communications network specifically designed to talk to spacecraft both in orbit and also deep space. It's called TerraNet, and it's at least 1,000 times faster than the radio communication systems currently used to communicate in space. Associate Professor Sasha Shedwi from the University of Western Australia node of the International Centre for Radio Astronomy Research says the project will be one of the first commercial optical communications networks in Australia to be capable of providing day-to-day support for space missions. The network's main commercial application will be transferring data to and from satellites orbiting the planet. One of the strongest drivers for increased data rates is the rise of advanced Earth observation and imaging satellites carrying hyperspectral cameras. These satellites take high-resolution images of the Earth's surface used for national defense and disaster management, in the process generating huge amounts of data. In fact, currently the data on some of these satellites needs to be compressed or thrown away because the capacity is simply not there to downlink at all. Shedway says by expanding to optical communications with a ground station network capable of supporting them, TerraNet will be able to use them to their full capacity. The project, which is being partly funded by the Australian Space Agency, will also explore high-speed communications in deep space, including the Moon, and will be capable of providing the communications needed for NASA's Artemis lunar missions. The initial network will be made up of 2 fixed ground stations, one at the University of Western Australia and the other at Mingeonoo, with a third mobile station initially deployed at New Norcia, and it should be operational by 2026. Shedway says NASA and other space agencies need communication stations worldwide in order to maintain continuous contact with missions as the Earth rotates.
The TerraNet project is about taking some of the cutting-edge technologies that were developed here at the International Centre for Radio Astronomy Research, located at the University of Western Australia, and translating those technologies into the world's first optical communications ground station network. This network will allow us to download critical data from satellites in space to Earth faster than has ever been done before. It allows us to also create commercialization opportunities for our industry partners, Goonhilly Australia, Thales Australia, and our other partners around the world, including the German Space Agency, the French Space Agency, and the European Space Agency. So with this project, we're going to be able to validate the commercial opportunities for this ground station and then have it be a revenue stream for income into the state going forward. One of the key challenges facing the world at the moment is with the explosion of satellites, the number of satellites in orbit and their increasing capability, we don't have enough bandwidth to get all that information down on the ground. One of the things that Terranet will allow us to do is move on to a new technology, optical communications technologies, and this will allow us to download information from space thousands of times faster than is currently possible.
That's Associate Professor Sasu Shedwi from the University of Western Australia node of the International Centre for Radio Astronomy Research. And this is Space Time. Still to come, the unusual origin of the Geminids meteor shower, and later in the science report, a new study shows that just like the modern-day white pointer, Carcharodon carcharias, the ancient giant shark Megalodon was also warm-blooded. All that and more still to come on Space Time. Every December, the Geminids meteor shower lights up the night skies of planet Earth. But mysteries surrounding the origin of this meteor stream have long fascinated scientists, because while most meteor showers are created when a comet emits a tail of dust and ice, the Geminids actually stem from an asteroid, a chunk of rock that normally doesn't produce a tail. Till recently, the Geminids had only ever been studied from Earth, but now scientists have used observations from NASA's Parker Solar Probe mission to study the Sun to deduce that the Geminids may have been created by a violent catastrophic event, such as a high-speed collision with another body or some gaseous explosion. The findings, reported in the Planetary Science Journal, narrowed down hypotheses about the asteroid's composition and history, which may explain its unconventional behavior. One of the study's authors, Jamie Soleil from Princeton University, says asteroids are sort of like little time capsules dating back to the formation of the solar system. They were formed when it was formed, and understanding their composition gives scientists another picture of the puzzle of the solar system's history. Unlike most known meteor showers that come from comets, which are made up of ice and dust, the Geminid stream seems to originate from an asteroid, a huge chunk of rock and metal catalogued as 3200 phaeton. The study's co-author, Wolf Kuka, also from Princeton, says most meteoroid storms are formed by way of cometary debris trails, so it's unusual that this one is formed from an asteroid. Additionally, the stream's actually orbiting slightly outside its parent body when it's closest to the Sun. When a comet travels close to the Sun, it gets hotter. That heat causes ice on the surface and inside the comet to release lots of gas, some of which drags bits of dust and ice with it, and that forms a halo around the comet nucleus and also creates spectacular cometary tails. This material continues to trail behind the comet as it stays within the Sun's gravitational pull. And over time, this repeated process fills the orbit of the parent body with material to form a meteoroid stream. But because asteroids, like 3200 phaeton, are made of rock and metal, they're not typically affected by the Sun's heat in the same way comets are. That leaves scientists wondering exactly what's causing the formation of 3200 phaeton's meteor stream across the night sky. Now, in the past, astronomers have seen bits of 3200 phaeton flake off the parent body under the blistering heat of the Sun around closest approach. It's also been suggested that 3200 phaeton, which appears to be on a cometary orbit, not that of a typical asteroid, may be a dead comet, one that's lost all its ice, leaving behind only a rocky core which resembles an asteroid. But this is where the new Parker Solar Probe data comes in. It shows that while some of 3200 phaeton's activities are related to temperature, the creation of the Geminid stream itself was likely caused by something catastrophic. To learn more, the authors used the new Parker Solar Probe data to model 3 possible formation scenarios, and they then compared these models to existing models created from Earth-based observatories. These different models reflect the chain of events which would transpire according to the laws of physics based on different scenarios. And the authors found that a violent collision with another object, or alternatively a gaseous explosion, rather than just being baked by the sun on a close approach, was most consistent with the Parker Solar Probe data, and probably best explains the Geminids we see now. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Archaeologists have discovered the oldest known cave engravings made by Neanderthals ever found in France. The findings, reported in the journal PLOS ONE, are thought to be over 57,000 years old. Based on the shape, spacing and arrangement of these engravings, scientists think they're deliberate, organised and intentional finger flutings created by human hands. Further dating of the cave found that it would have become closed off by infilling sediment around 57,000 years ago, long before Homo sapiens were established in the region. This, combined with the stone tools found in the cave, strongly suggests the engravings are the work of Neanderthals, and suggested their behaviour and culture may have been similarly complex and diverse as those of Homo sapiens. A new study has found that as men age, some of their cells lose the very thing that makes them biological males, their Y chromosomes. And it turns out this loss hampers the body's ability to fight cancer. The study, reported in the journal Nature, found the loss of the Y chromosome helps cancer cells evade the body's immune system. This apparently common impact of the aging process in men results in aggressive bladder cancer, but somehow also renders the disease more vulnerable and responsive to a standard treatment called immune checkpoint inhibitors. Now, based on their research, scientists are developing a test for the loss of the Y chromosome in tumours, with the goal of helping clinicians tailor immune checkpoint inhibitor treatments for male patients with bladder cancer. A new study shows that one of the largest carnivores ever to live on the face of the Earth, the gigantic shark Megalodon, was warm-blooded. The findings, reported in the journal The Proceedings of the National Academy of Sciences, confirms that Megalodon's body temperature was much higher than previously thought. Megalodon, which lived in the oceans between 23 million and 3.6 million years ago, could reach lengths of over 20 metres or 60 feet, and was the apex predator of the ocean during its reign. Previous studies had suggested that Megalodon was likely warm-blooded, or more precisely, regionally endothermic, just like some modern-day sharks, including Carcharodon carcharias, the great white or white pointer, with previously reported average body temperatures ranging from 22 to 26.6 degrees Celsius, which could be between 10 and 21 degrees Celsius higher than ambient ocean temperatures. However, the new study instead suggests that Megalodon had an overall average body temperature of 27 degrees Celsius. And while previous studies were based on pure inference, the new research provides the first empirical evidence of warm-bloodedness in the extinct shark. See, the research team used a novel geochemical technique. It involved both clumped isotope thermometry and phosphate oxygen isotope thermometry in order to test the Megalodon endothermic hypothesis. The new study found that Megalodon had a body temperature significantly higher than sharks, considered cold-blooded or ectothermic, consistent with a fossil shark having a degree of internal heat production as modern warm-blooded animals do. Hackers find a new way to get around voice authentication security systems and using artificial intelligence to determine which songs are likely to be hits and which are misses. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, computer scientists at Canada's University of Waterloo have discovered a method of attack that can successfully bypass voice authentication security systems, and they're claiming up to a 99% success rate after only 6 tries. Now, obviously, this is bad news for the voice authentication systems used by banks and government departments, call centers, etc., where they let you log into services by voice. And normally, you enroll your voice print by repeating a certain phrase in your own voice. The system then extracts your unique vocal signature or voice print, and you can log in, and when you repeat a different phrase in the future, it will compare those two. But obviously, hackers figured out they could use deepfakes to generate convincing copies of your voice And so that obviously led the people making voice authentication systems to come up with defenses, spoofing countermeasures. But the University of Waterloo researchers have identified markers in deepfake audio that betray that it is being computer generated. And they wrote a program that removes these markers, making it indistinguishable from authentic audio. So they tested it against Amazon Connect's voice authentication system. Now, that's a bit more advanced. They only had a 10% success rate in one 4-second attack. This rate rose to over 40% in less than 30 seconds. But with some of the less sophisticated voice authentication systems they targeted, they achieved a 99% success rate after 6 attempts. And they're saying that the only way to create a secure system is to think like an attacker. If you don't, you're just waiting to be attacked. And they say that by demonstrating the insecurity of voice authentication, we hope that companies relying on voice authentication as their only authentication factor will consider deploying additional or stronger authentication measures. And this is where it's very important to use the Google or Microsoft or some sort of other authentication app and not rely upon the SMS messages that come through. Because if somebody steals a SIM card out of your phone or convinces a phone company to transfer your SIM over to an eSIM in one of their phones, and you have all of your banking and other systems set up to receive an SMS message, they'll get those messages, you won't. And a lot of people have been caught that way. So definitely use as many factors of authentication as you can. And voice is sadly not invulnerable.
And the other big story this week has been AI has now moved into the music industry in a different way to what one might expect by looking at your heartbeat and being able to work out what you're into.
Yeah, look, this is because the US entertainment magazine Variety revealed last year that there are over 100,000 songs released every single day to all the major streaming services like Spotify, Apple Music, and others. And the problem is that whether it's using human intuition aided by existing algorithms to analyze the song's lyrics and other metadata to predict hits, they're only getting about a 50% success rate, which is sort of 1 in 2. So Paul J. Zak, a professor at Claremont Graduate University and the senior author of this study, was telling ZME magazine that they use neurological data and AI techniques to see how our brains respond to music. And Zach stated that my lab previously identified what appears to be the brain's valuation system for social and emotional experiences, which is called immersion. And in talks with the streaming service, he says they told me that they struggle to suggest new music for subscribers due to the high volume of new music. I mean, 100,000 songs every day is a lot. I mean, sadly, most of it's crap. All the hits are from the last century. But so he says that he thought that measuring this neurologic immersion could help solve the problems. And so he had 33 participants from the university campus and from the surrounding community, and they fitted them with non-invasive neurophysiological recording devices using commercially available off-the-shelf devices such as cardiac sensors on smartwatches. And then they fed this data into their immersion neuroscience platform, which uses this data, including a person's heart rate, to infer neural states from the activity of cranial nerves. And so basically by using these brain signals, they looked at 24 recently released songs from a streaming service, and they looked at 3 months of data to see whether the song was a hit or not based on the number of plays. And this set of songs included both hits and flops and at least 700,000 listens on a particular service. They basically could tell that from their results, when people were listening, they could tell 97% of the time whether the song was a hit or a flop. And the strength of the system lies in the fact these signals can be measured with something as simple as a smartwatch or fitness armband, whereas brain activity is typically recorded using cumbersome lab equipment. So whether this means we're going to hear a sea of sort of same songs that AI says is a hit or not, I don't know.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.